Chapter 6 requires that buildings and building sites be designed, constructed, commissioned, and operated for the effective use of energy. This can be found in Section 601.1. Chapter 6 is intended to provide flexibility and permit the use of innovative approaches to achieve the effective use of energy in new building construction. As indicated in Section 1002, additions must comply with the requirements of the IgCC for new buildings, inclusive of the energy requirements of Chapter 6. Energy requirements for alterations to existing buildings, however, are located in Sections 1003 and 1007.3 of the IgCC. The IgCC requires that all buildings that consume energy comply with the requirements of 603, Energy Metering, Monitoring, and Reporting, 609, Specific Appliances and Equipment, 610, Building Renewable Energy Systems, and 611, Energy Systems Commissioning and Completion. Where indicated by the jurisdiction in Table 302.1, buildings must comply with the Automated Demand Response Infrastructure requirements of Section 604. The IgCC contains both performance and prescriptive-based energy compliance paths. These paths are generally available for buildings of all sizes and occupancies. However, where the jurisdiction requires enhanced energy performance in Table 302.1, the performance path must be used to demonstrate compliance, except that Section 302.1.1 exempts buildings that are 25,000 square feet or less in total area from enhanced energy performance requirements. In addition to the preceding list of requirements that are applicable to all buildings that consume energy, buildings designed on a performance basis must comply with 602 Model Performance Pathway Requirements and 608.6 Plug Load Controls, and buildings designed on a prescriptive basis must comply with 605 Building Envelope Systems, 606 Building Mechanical Systems, 607 Building Service Water Heating Systems, and 608 Building Electrical Power and Lighting Systems. Let's take a look at how the Rhode Island School for the Deaf used the 2012 IgCC standards in their green design.
My name is Christopher Armstrong. I'm an architect with the Robinson Green Beretta Corporation, the architect of record for the Rhode Island School for the Deaf you see behind me. We're here in Providence, Rhode Island, and we're here to talk about the School for the Deaf and its green features. The building has got solar shades, and the solar shades kind of serve the dual purpose in that, one, they help reduce the heat gain on the glazing on the building, and secondly, they reduce the glare for the lighting on the interior of the building, which is critical to the deaf and hard of hearing population because it allows them to be able to better read people's lips and see sign language. The building envelope itself, it's a high-performance building envelope. Insulation values vary between 20 and 30% above what's required by code. The glazing itself is a high-performance glazing with low E coating. U values around 0.3, and we also integrated in semi-translucent glazing in the upper lights of the windows to help draw light further into the space and to also help minimize the glare that we spoke of with the solar shades. All of the roofing has a high reflectance, and it all meets Energy Star requirements. And you can see the primary mechanical penthouse is peeking up from over top of the features, so it helps reinforce the massing of the building and also houses the mechanical units, which we can talk about later, which help with the energy efficiency of the building. Yeah, low flow and dual flush water fixtures. So the labs, they're low flow and they're on timers, and then the water closets are, depending on whether the men's room, they're low flow, the women's room, they're dual flush, and then the men's rooms also have the low flow units. These units all service the gym. The gym was actually, the existing gym of the original building on the site was actually kept, and then all the rest of the school was built off of that. And the whole existing gym, the envelope improvements were done, insulation was added for both the walls and the roof. We put windows back in to get some natural daylighting back into the gym. And you can see these units are an example. And these are actually small scale in comparison to when we go up. You'll see the big DOASs upstairs. But then you can also see the variable frequency drives that go along with the systems to make sure they're not working any harder than they have to based on the demand that's being sent up to them. as I was explaining, these 4 pipes right here are the main hot and cold water pipes that come from the central boiler and chiller rooms. And what they do is they come up here, they service the heating and cooling coils in these units, which are what condition the air for the dehumidification purposes, for the ventilation supply air. And then each one of these units also have dual enthalpy energy recovery wheels. So all the return air that's coming back through, it'll use the heat or the cool of the return air coming back in to help precondition the new outside air being brought in before it's fully conditioned and then sent out to the spaces themselves. All of the roof surfaces on the building are Energy Star compliant. The low slope white roof has the highest reflectance, and then all of the other sloped metal roof surfaces are a light enough color where they also qualify for Energy Star and reduce the overall heat gain of the building.